Hello, we are the YouTube trending analysis video group, and we will be presenting on our final project today. My name is Bryce, and my project members are Kunal and Jack. So for a small recap on what our project is about, essentially we're trying to demystify the YouTube algorithm a little bit so that content creators can have a better idea of what are good metrics to be able to tell how well a video will trend or how many views a video might receive. And this is mostly because creators often ask for their viewers to like and comment. And so we assume that these are good features to determine the number of views a video might receive. And it's something that we're exploring with this project. Another thing that we look into is whether or not clickbait titles are something that is relevant or prevalent in common trending videos. And we'll talk a little bit more about that later on. So on the slide, you can see our regression analysis for the likes count and the comment count. And this is on the right-hand side. And these are for the top 5 categories within the data set. So what we can see is for likes and comments, for the most part, it's pretty linear, although it is logarithmic for something, let's say a comedy in the likes count, which leads us to wanting to confirm the correlation of these with view count. So essentially you can see on our heat map that we've created that likes, dislikes, and comment count are pretty good, are well correlated. And so these are good features that we will be using for our XGBoost model, which Jack will talk about in the next slide.
So our first step with the data pre-processing was to transform the title data from natural language into a feature that could be utilized by our main model. So the first step that we used to perform this was we calculated the proportion of each title that was capitalized, as we felt that this could act as a proxy for how clickbaity a video title was. The next step we did was we used similar techniques to those that we used in homework 4 to build a spam classifier, where we constructed a dictionary containing the most commonly used words in all the titles. And then we ran a linear regression on the training set on only those words that are included in its title. And we used the output of this linear regression, we used the prediction of it on the training and test data set as an extra feature to be utilized in our model. We then fed these 2 extra features in addition to our data set into our main model, which is called XGBoost, and that is an implementation of a gradient boosted tree. It's an ensemble method of weak learning decision trees, and it has a primary focus on speed and performance. And using this model, we hope that we'll be accurately able to predict that how many views a trending video will receive, given all of these features. Next slide, please. So the very first untuned version of our model achieved an average relative error of about 0.52 on our test data. And this isn't too great, but the XGBoost model has a very large number of hyperparameters available for tuning, ranging from the number of iterations to the learning rate to the regularization terms. And so we hope that with extensive tuning, we can significantly decrease this error. One other thing we're hoping to implement is a metric that other researchers on this data set used called views ratio. And this is a measure of how many more views a given video receives than other videos trending on the same day. And so essentially what it's measuring is how much more popular this given video is than all the other ones. And so we hope to implement this feature, and we're going to perform correlation analysis and add it to our data set and see if it's worthwhile or boost our performance at all. Thank you.